Hello everyone. I am Praveen BR, Assistant Professor, Department of Electrical and Electronics Engineering, teaching you all microcontroller lab program for 5th semester electrical students. The subject code for the microcontroller lab is 18EEL57 or 17EEL57 for both 2017 and 2018 scheme. So let us execute a program, an assembly language program, wherein we are finding out the square and cube of a given hexadecimal number. So the number is stored in 9000H external memory location. The output is checked for a square in memory location 9001 and 9002. Whenever we are finding out a cube, the number is stored in 9000, whereas the output is checked in 9001, 9002, and 9003 memory location. So let us see how to execute the square and cube of a given hexadecimal number. To execute this, we use a software called as Keel Microvision. So Keel Microvision is this software where there are three windows. One is called the project window, one is called the editor window, one is called the build output. So let us start with the program. So how do we start with the program? Step one, in the menu bar, the fourth tab is the project. So click on the fourth tab, project. In the project tab, click on new microvision project. You will be asked to enter the file name here. So enter the file name as SQUARECUBE, which indicates that I'm calculating the square and cube of a number. After typing the file name, please press save. It will ask you to choose the device with the vendor name. The vendor name here we choose is microchip, and the device we choose here is AT89C51ED2, which is compatible with the Keel Microvision software for 8051 programming. So in the search window here, I type capital A, capital T, 89, I type capital C, I type 51, and I type ED2. So you can see here, you obtain this microchip where the vendor is microchip. The device name is AT89C51ED2. Here, I get to know that this particular device is compatible for 8051 programming. What do we do here? We press OK. Here, since we are not doing the experiment related to interfacing, where an external software is not used to check the output, we are not copying the image of the file. So here I press no. So as soon as I press no, in the project window, the target gets created. We can observe here the target is created. Now I have to type the program. Where can I type the program? The program is typed in the editor window. How do I enable this editor window? Editor window can be enabled. In the menu, we have to go to the file. In the file, we have to go to new, which enables the editor window. Here, I type the program. I have typed the program. So after typing the program, here I click on file. I click on save as. It asks me to type the file name in terms of assembly language programming. So the extension file for the assembly language is .asm. So I give here as squarecube.asm, which indicates that I am creating an assembly language file. So I click on save. Now I have to create the crystal frequency. I have to generate the crystal frequency of 11.0591. How do I generate it? In the project window, under Square Cube project, you have to right click on target. You have to choose options for target one. You find by default 33.0. So you have to, in the place of 33.0, you have to type 11.0591 megahertz, which is the crystal frequency that we use for 8051 microcontroller. In the output tab, we have to check create hex file. By default, the create hex file will not be checked. So by clicking here, it gets checked. After checking the create hex file, you press OK. Now I have to add the file to the given project. How do you add the file to the given project? We have to expand in the project window, target 1. We get source group 1. We have to right click on source group 1. Here, there are many options. We choose add existing file because we have already created the hexa file. So I click on add existing file to the group. Here I give the name as square cube .asm. I choose this file and I click on add once and I press close. So this is going to add the file to the project. Now I check for the errors by translating, which says in the build output that there are 0 errors and 0 warnings. I link the hexa file by building. This links the hexa file. Next, I rebuild to complete the process. Now I have to check the output. Output is checked by clicking the debug tab in the menu window. I click on start stop debug session. I get this dialog box where I have to press OK. I am taken to the screen. In the screen, I have to go for the memory window. Here I am checking the output in 20H memory location. So I type over here D colon, which indicates that D colon indicates that it is the internal memory location. In the same program, I have to check for square of a given number and the cube of a given number. To distinguish whether I am performing square or cube in 30H memory location, I type as 02. So 02 indicates that I am calculating the square of the given number. So let us check how to see the square of the given number. To input the hexadecimal number in 9000H memory location, in the menu bar, I choose view window. In the view window, I choose memory window. In the memory window, I choose memory 2 window. I am going to choose external memory location. So I type in the address bar X and colon. I want to input my hexadecimal number in 9000H memory location. So I type 9000H and I press enter. The hexadecimal number I am giving over here is 54 or 56 is the number. When I multiply 56 into 56 in hexadecimal, I get E41C. E41C is the number given for a square of a given number. So let us proceed with the program. So after giving the input in 9000, the output is obtained in 9001 and 9002. So let us check the output. So how do we start the execution? We press F11 or the third tab in the file menu, which says step. So after pressing this, we go to the DPTR memory location. So the DPTR is pointing towards 9000H memory location. The data present in 9000 is 56. So the data is brought to the accumulator. Since I have to fetch the data, since the same data has to be used for the cube also, I keep this number in one of the registers. I can use R0 to R7, any of the registers. So I keep it in register R0. Next, I am going to multiply the data. So to multiply, I can use only two registers, that is accumulator and register B. So the same number which is there in the accumulator is brought to the register B. So when I say move B comma A, 56 is brought again to register B. Now we know to find out the square of the number, we are going to multiply 56 into 56, which gives me the answer as E4 1C. So you can see E4 1C. E4 is the lower bit which is stored in the accumulator. 1C is the higher bit which is stored in register B. Now, how do I know whether this is the square of the number, and how do I know that I have done the square only? This can be kept, the answer can be kept here by checking the bit. How do we do this? We check whether one of the bit in the memory location, 20H, what is the number? So if I give the number as 02, it indicates that it is the number given here in 20H memory location. I am, if 1 is the bit amongst the 8 bits, it indicates that it is the square of the number. Otherwise, if everything is 0, it indicates that I'm calculating the cube of the given number. So it is going to check whether the bit is, it will check whether the bit in the 20H address is, the memory location is whether 00 or 01. So first it is going to clear the carry bit. Now it is going to check the 20H memory location. 02 is written as 0000 and 2 is written as 0010. Since one of the bit is 1, here it checks for that particular bit. Jump a bit 01 to the last. It means that if one of the bit over there is 1, it goes to the storing the answer. So let us check whether it goes to the storing the answer. Yes, it is going to the last step. Here it increments the DPTR. So 9000 gets incremented to 9001. The data present in the accumulator is E4, which is stored in 9001. We can observe it here. In the memory location 9001, E4 is stored. Now I have to store the higher bit 1C in the memory location 9002. So how does it happen? It is going to add the data that is present in 9002 memory location, and it is first it is going to increment, and then it is going to perform this operation. So this is how 56 into 56 is E4 1C. Now in the same program, I can also check whether I am calculating the cube of the given number. How do I do? How do I calculate the cube of a given number? I go to 20H memory location. In the place of 02, I type it as 00 and I save it. I go to the reset, which says that I'm starting the program again. Now I start the program once again. So again, 9000H memory location, it stores in DPTR. So DPTR, the number that you have stored is 56, which comes to register R0. Again, 56 is stored. So 56 into 56 is E4 1C. So it gets multiplied. Now I want the cube of the number. Now it is going to check whether the memory location 20H is 0 or 02. If it is 0, all the bits are 0. So it does not go to last. Instead, it pushes the data that is present in register B to the stack. So it pushes the data to the stack. That is 1C is pushed to the stack. Now, the data 56, which is present in the accumulator, is going to, or the data that is present E4 is going to be brought to the register P now. Now, E4 is multiplied with 56 after bringing it to the accumulator. So, E4 into 56 will give me the cube of the given number. So, the cube of the given number is 4C98, which is stored in the memory location, that is in this memory location. So after this is performed, the multiplication is performed, the DPTR will increment to 9000. The data present in the accumulator 98 will be stored in 9001 memory location. The higher bit 4C will be stored in accumulator now. 4C, after that we are popping the data, that is 1C, back to the B. So 1C comes back. Now the data that is present in R0 is going to be moved to accumulator, that is 56. Now we multiply over here the data 56 with 1C. You get 0968 or 6809. 09 is the higher bit, 68 is the lower bit, which is going to get added with 4C. So 4C gets added with the number. We get B4, which will be stored in 9002 memory location. The next number will be stored in 9003 memory location. So that's how we get the answer for the cube of the number 56 into 56 into 56 as 98B40900. So that's how we perform the square and a cube of a given number. Thank you for watching this video. Thank you.